Hi, I am Shen, and this is my project for Tinkercad on the social distance indicator with light and alarm warnings. Due to the COVID-19 pandemic, it is important to maintain social distance in order to prevent spreading of the virus between different individuals. Therefore, this designed social distance indicator model is idealized for smart devices such as smartwatches for the sake of dependability and convenience for the user. The circuit comprises of Arduino Uno and components such as ultrasonic distance sensor, NeoPixel 16-ring RGB LED for visual light warning, piezo for audible alarm warning, and an LCD display for written word warning, ensuring that the device is useful and effective. Alright, so the simplified version of the model circuit can be laid out as such. So first of all, we have our Arduino Uno, which is connected by two different breadboards, and they consist of the different components connected, which first of all includes the ultrasonic distance sensor, and next to it we have the NeoPixel Ring 16 RGB LED, and here we have the piezo, which will act as an alarm, and an LCD screen over here to flash the warning signals, and that LCD screen is connected to a potentiometer at currently 250 kilo ohms in order to adjust the proper brightness for the LCD display. We also have two different resistors here. The first one is connected to the piezo and set at 1 kilo ohm resistance in order to output the correct loudness of the alarm volume so as not to be too overwhelming but is still audible to the people that we want to warn. And the second resistor is set at 220 ohms, which is standard for the regular components that we use in a circuit. Alright, so now we're going to look through the important sections of the C++ code that we have developed for this system and see how it is able to act as a social distance indicator with light and alarm warnings. First, we have to include the NeoPixel library as well as the liquid crystal library, which is for the LCD display. Then we set the LED number to 16 as we are using a NeoPixel 16 ring, and the next step will be to initialize and set the value of the pins based on the number that they are connected to by the different components as shown here and here for the LCD. Next, we are going to set the minimum distance to 100 centimeters and the maximum distance to 300 centimeters, which will be the range of distance that will be picked up by the ultrasonic sensor in order for a response to be given. The buzzer pin is then set to output so that the piezo can properly act as an alarm, and the trigger and echo pins of the ultrasonic sensor are set to output and input respectively so that they can properly send and receive ultrasonic signals and determine the distance between an object and itself. Next, we need to program a function that is able to calculate the distance between the sensor and the object at any given instance and to return the value of the distance so that the proper responses can be made. So these responses are based on the conditions over here in which the code is programmed in such a way that if the object is further than 300 centimeters away from the sensor, that only one LED light will light up. However, as the distance between the object and the sensor gradually decreases from 300 centimeters to 100 centimeters, more and more LED lights around the ring are going to light up in increasing intensity and color until it reaches all 16 lighted up LEDs. So when all 16 of these LEDs are lighted up, it will send a signal here and cause the piezo alarm to go off and for the LED screen display to change from "you are safe" to "social distance violation" to indicate that that object is within the 100-meter radius. Alright, so we have started the simulation, and as we can see, the object is currently more than 300 centimeters away from the sensor, and based on the serial monitor display, we see that the number of glowing LEDs is only 1, which is true based on what we observed from the NeoPixel ring over here. Furthermore, we also see from the LCD display that safe distance appears, indicating that the object is not within the 100 centimeter radius from the sensor. So now let's see what happens as this object gradually approaches and its distance decreases from 300 centimeters to 100 centimeters. So already we can see from the ring and the serial monitor that the distance is decreasing and the number of LED lights are increasing as well, from green to yellow, to orange, to red, and let's see what happens when all of the red lights up. So when this happens, the distance is deemed to be less than 100 centimeters, and the alarm goes off, and the LCD shows the display of social distance violation. So what has to be done is the object has to retreat until it is out of the 100 centimeter radius as shown, and the alarm goes off, and the LCD is back to the safe distance display. However, as we can see, the lights that are lighted up in the LED is still a lot, as it is still quite near to the 100 centimeter radius. So as this object gradually backs off, the number of LED lights also decreases, indicating that the object is getting further and further away from the sensor until it gradually leaves the 300 centimeter radius as shown, and only one LED light in the ring remains lighted up. So that is it for this model, and I hope you enjoy this video and simulation, and thank you for watching.